Kia ora year 12 and 13. This is part 2 of question 2a from 2006. So this part is the bit where we've done the trig identity stuff. So we've shown that we can write cos of pi on 8 like this. And we also, in the first video, worked out the value for sine of pi on 8. And we found that that could be written as, it's very beautiful and symmetric. We could write that as this. So we're going to use both of those two things in this part, which is where I'm going to solve this quadratic equation. Z is a complex number, and we're going to give exact forms in the solution a plus ib. So my basic method here is going to be to do something first of all with this, right? So do the obvious thing with that, and then use de Moivre's theorem and work in polar form, and then end up back in rectangular form, a plus ib form. But there's another way that you can do the whole question where you don't use this result at all. I'll probably do a part 3 of that video, but maybe not today. So we're going to start off by looking at z squared equals, what is it, 1 plus 7i over negative 3 plus 4i, and thinking that that looks horrible. But what I do whenever I see division of complex numbers like that is I multiply numerator and denominator by the conjugate as follows. So we're going to start off like this, and we'll find that things get very straightforward from that point on. In fact, in some ways, from here, if we were using a calculator and getting a decimal approximation, this question would now become probably about merit level, level 3, but it doesn't feel like it yet. So in the numerator, we'll do the denominator first. Sorry, we've got 9 plus 16. Numerator gives us negative 3 minus 21i minus 4i minus 28i squared. So that simplifies to z squared equals 25 minus 25i over 25, which is 1 minus I. Right, we should be feeling pretty happy here because now we've got down to this. Z squared is equal to root 2 cis of negative pi on 4. Now, I knew that so quickly because in my head, as soon as I see 1 minus I sketch my wee argon diagram and I plop 1 minus I there. And I'm using my knowledge of special triangles, right? So I know that it's going to be root 2 and the angle is negative pi on 4 or negative 45 degrees. When we're using de Moivre's theorem, though, it makes sense to think of it not as just negative pi on 4, but as negative pi on 4 and any full circle rotation. So negative pi on 4 plus 2n pi. We know that here we've got a quadratic, so we know we're going to end up with 2 solutions to the equation. So now we're going to say z equals r cis theta, and we're going to apply de Moivre's theorem. So we have r cis theta squared is equal to root 2 times this, giving me r squared cis 2 theta is equal to root 2 times this thing here. And our next step is to match up the r squared with the root 2 and to match up the 2 theta with this stuff here. So r squared is root 2, r must be positive, so r is equal to the 4th root of 2. Later on it's going to be useful to think of that as this. Not essential, but it's going to make it nicer. Now, what about my angle? Well, I've got 2 theta is equal to negative pi on 4 plus 2n pi. Remember, our goal is to work out r and theta, so theta is equal to negative pi on 8 plus n pi. So z is equal to r cis theta, and you can suddenly see where that pi on 8 from way back at the start comes from. So let's do n equals 0. Z is equal to the 4th root of 2 times cos of negative pi on 8 plus I sine negative pi on 8. Right, so that's just substituting in 0 there. It's going to be my principal solution. So cos of theta is even, which tells me that cos negative pi on 8 is simply equal to cos of pi on 8. Sine of theta is odd. It's an odd function, and that means that sine of negative pi on 8 is equal to negative sine of pi on 8. So we can write z, we'll call this z1. So z1 is equal to this. Right, so cos of pi on 8 from way back at the start was root the square root of blah 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 minus I, and you can see the benefit in doing the Pythagoras stuff in the last video now, right? We've worked out our value of sine of pi on 8. If you hadn't done that earlier, and in the exam there's no reason you probably would have, you'd now have to look at this, have a brief moment of freak out, and then do your Pythagoras thing. Okay, so cleaning all of that up, what does it give me? Well, I've got the square root of 2. This is where this starts to come in handy. I think you'd get a full tick for that, by the way. It's just that this is slightly more elegant. So what I've done here is that I've written this like this, and the same thing in here, except that on this part of it I've naughtily chucked 2 steps together. Remember that root A, root B is just equal to root AB. Okay, so here, the nicest possible way to write Z1 is like this. These two together gives me 2 plus 2 root 2 over 2 minus I times 2 root 2 minus 2 on 2. Now, that's my first Z value. Let's just go back and see what my second one's going to be. So that was where I substituted n equals 0. What happens when I substitute n equals 1? Well, Z2 will be the 4th root of 2 cis negative pi on 8 plus n pi plus 1 pi. But the good news is we can do this very quickly using the graph and some symmetry. So this is cis of 7 pi on 8. Now, just sketch yourself a little diagram. The first one was negative pi on 8, and the second one is with pi added on. So that's 7 pi on 8. But we can see that those A and B values are just going to have the opposite signs to each other, positive and negative value. So, let's see if I can get this right. So Z2 is going to equal, instead of having a positive number here, this is going to be negative, and this one's going to be positive. So Z2 will be negative times whatever that thing was, plus I times that thing. Right, I'll just go back up and check what those numbers were again. Right, 2 plus 2 root 2. And the complex part, I mean the imaginary part is this, so plus 2 root 2 minus 2. Okay, so there is loads of really great stuff in this question. The best way to get the most out of these is to leave this question now and come back to it in another few weeks and just see how much of it feels really comfortable with a little bit of time. And then if there are things in here that you're not happy about, go and grab the Delta textbook or Education Perfect and brush up on the individual skills that go into the question. I will do a third video going through how to do this without using polar form, because in some ways I think that's the most straightforward way to do the problem. But we were given a clue and told hence or otherwise. So usually if it says hence, my first approach is to try to use the clue that we're given. Okay, thanks for watching, and just leave me any questions in the comments box.